Hi, welcome to another tutorial. In this video, I will show you how to use an analog multi-tester. But before that, if you are new to this channel, please consider subscribing to support this channel. Thank you. The topics that we will discuss are the different parts and functions, and the procedure on how to use ohmmeter, DC voltmeter, AC voltmeter, and ammeter. Now, let's begin by exploring the parts and functions of analog multi-tester. This is the indicator pointer. It is the one that gives the meter reading. While this part is what we call the scale plate, it is where the scale of each meter is located. This is the ohmmeter scale. When we are using ohmmeter in measuring resistance, it is where we should look for to determine the resistance reading. On the other hand, this is the voltmeter and ammeter scale. It is where we look for in determining DC or AC voltage reading and ampere reading. While this one is called zero corrector adjustment screw. It is used to adjust the pointer to zero at the left side. Here, we can see that the pointer does not align on zero. To adjust this, we will turn the screw in clockwise direction until the pointer reaches at zero. Always bear in mind that before using the tester, ensure that the pointer is aligned to zero at the left side, in order for the tester to give an accurate measurement. Meanwhile, this part is called selector range. It is intended to select the proper function range for specific measurement. For example, if we wish to use ohmmeter, all we have to do is to rotate this and point it to the ohmmeter setting. If you want to use AC voltmeter, just rotate the selector range on this part. When using DC voltmeter, we'll rotate the selector range here. If you will use the ammeter, set the selector range on this area. These are the test probes. We use it to place the terminal of the device or component we are measuring. And lastly, the 0 ohm adjustment knob. When using ohmmeter, we need to calibrate our tester. In doing, for example, let us set our tester to X10 ohmmeter. To calibrate, we have to short the two test probes. As we can see, the pointer deflects on the right side of the meter scale. Always remember that when shorting the two test probes, the tester must point on the 0 ohm. However, this is not the case, so we need to calibrate it by adjusting the 0 ohm adjustment knob. Just rotate the knob slowly until the pointer reaches the 0 ohm. Take note that before using any setting on the ohmmeter, always calibrate the tester for it to give an accurate reading. Let's proceed in learning how to use ohmmeter. The first thing we need to know when using ohmmeter is how to interpret the ohmmeter scale. As we can see, there are gaps in between, which do not have indicated numbers. To fully understand it, we will make a list of numbers from 0 to infinity with its individual scale and interval. From 0 to 2, the interval is 0.2. For 2 to 5, we have 0.5. 5 to 10, it's 0.5. For 10 to 20, the interval per line is 1. 20 to 30, interval is 2. And 30 to 50, interval is also 2. While 50 to 100, we have 5. Interval for 100 to 200 is 20. 200 to 500, interval is 100. While 500 to 1K is 500. And 1K to 2K, we have an interval of 1000. However, if you don't want to memorize this table, we can interpret the ohmmeter scale in this manner. For example, in 2 to 5, we will take the difference between 5 and 2, which is 3. Now, let's count the number of line from 2 to 5. Here we have 1, 2, 3, 4, 5, and 6 lines. To get the interval, we'll divide the difference in the number of lines from 2 to 5. So 3 divided by 6, we have 0.5. The answer we get is similar to the table. If we count each line from 2 to 5 using 0.5 interval. Here we have 2.5, 3, 3.5, 4, and 4.5. Now, let's have another example. This time, we'll interpret the range 20 to 30. As we count the number of lines from 20 to 30, we have 1, 2, 3, 4, and 5 lines. The difference of 30 and 20 is 10. If we divide it by the number of lines, we get 2. Therefore, 2 is the interval of the range 20 to 30. Now, if we count the lines with 2 as interval, here we have 22, 24, 26, 28, and 30. That is how we interpret the range of ohmmeter. Let's move on to the different ohmmeter setting that we can use in measuring resistance. Here we have 5 settings. These are X1, X10, X100, X1K, and X100K. X100K is rarely used. The common setting often used are these settings. Take note that these settings stand as multiplier. Whatever reading we get from indicator pointer, we need to multiply it to the setting we are using. For instance, if we set the ohmmeter to X10, resistance then is equivalent to reading times 10. The setting on ohmmeter also tells us the maximum resistance it can measure. For example, in X10, the maximum resistance it can measure is 20 k ohms. It is because the largest number we have in the ohmmeter scale is 2K. If we get the product of 2K and 10, we have 20K. Now, let's try to measure the resistance of this resistor. This resistor has 3.3 k ohms of resistance. The setting that we should choose must be capable of measuring this amount of resistance. Here, we cannot use X1 setting, since the maximum resistance it can measure is only 2 k ohms. The settings that we can use can be either X10, X100, or X1K. We will just leave it as is to use the X10 setting. First, before using ohmmeter, we need to calibrate it to get the accurate reading. Just short the 2 test probes, then adjust the 0 ohm adjustment knob. Our expected resistance reading is 3.3 k. And the pointer must deflect somewhere around here. As we test the resistor, we can see on the meter scale that the pointer deflects on around 300 plus. Therefore, the resistance is approximately 3.3 k ohms. Now, we'll move on to AC voltmeter. It is necessary to understand the relationship between AC meter setting and AC meter range. Here we have 3 meter range scale. These are 0 to 10, 0 to 50, and 0 to 250. When using the voltmeter scale, it must be according to the setting being used for measurement. Example, if we set the tester to 10 AC volt, the meter range that we should look for must be 0 to 10. However, if we set it to 50, we'll use the 0 to 50 range. For 250 AC, 0 to 250 range must be used. Meanwhile, when using 750 AC volt setting, we will use the range 0 to 10. But this time, we'll use a multiplier of 100, and whatever reading we get must be multiplied by 100 to get the AC volt value. Also, in voltmeter, it is a must to learn how to read the voltmeter scale. Here, I will show you the different intervals, or the volts per division, in every range. For 0 to 10, the intervals per division is 0.2. For 0 to 50, we have one interval per division, while for 0 to 250, the interval is 5. However, if you wish to know how to get the intervals per division in every range, all you need to do is, for 0 to 10, count the number of lines, from 0 to 2 only. It is because we have even distribution of lines in every meter range. Here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 lines. And then, get the difference of 2 and 0, which is obvious to be 2. And divide it by the number of lines. Therefore, the interval is 0.2. For 0 to 50, just divide 10 by the number of lines from 0 to 10. Then you get 1 as interval. Also, for 0 to 250, divide 50 by 10. And that's how we get 5 as interval. In measuring AC voltage, the setting that we use must be greater to the expected voltage that we are measuring. For instance, let's try to measure the output voltage of convenience outlet. Here we expect a reading of around 220 volts. Therefore, we must use either 250 or 750 AC volt setting. I am going to use the 250 setting. Let's connect the test probes to the terminal outlet. As we can see, we have a reading of around 230 volts. In DC Voltmeter, this are the setting we can use. For 0.1 setting, the meter range we should look for is 0 to 10, with 0.01 as multiplier. Multiplier is derived by dividing 0.1 by 10. In 0.25 setting, meter range is 0 to 250. And the multiplier is 0.001. If we use the 2.5 setting, meter range is 0 to 250. Its multiplier is 0.01. For 10 DC volt setting, meter range is 0 to 10, with 1 as multiplier. While 50 setting has 0 to 50 as meter range, and 1 is the multiplier. For 250, meter range is 0 to 250, also we have 1 as multiplier. While 1000 DC volt setting, meter scale is 0 to 10, but this time, its multiplier is 100. For 0 to 10, the intervals per division is 0.2. For 0 to 50, we have one interval per division, while for 0 to 250, the interval is 5. Interval or volts per division is exactly the same as AC voltmeter, since we are using the same meter range scale. Now, let's move on to actual measurement. In here, we have a 9 volts battery. Let's measure the voltage across this battery. Let's set the tester to 10 DC volt. Connect the red test probe to positive terminal, and black test probe to the negative terminal of the battery. Here we get a reading of 8.4 DC volts. For DC ammeter, these are the settings we can use in measuring current. Here we have 0.25, 25 m or milli, 2.5 milli, and 50 micro. If we use 0.25, the meter range we shall look for will be the 0 to 250, and we will use a multiplier of 0.001. If we set the ammeter to 25 milli, still the meter scale is 0 to 250, but the multiplier is 0.1, and the value of current will be in milliampere. For 2.5 milli, we still have the same meter scale of 0 to 250, while the multiplier is 0.01. Also, the value of current will be expressed in terms of milliampere. Meanwhile, using 50 micro as ammeter setting, its meter scale is 0 to 50, with 1 as multiplier, while the value of current will be in microampere. Now, since we already know how to interpret the meter scale, as we have discussed previously in using AC and DC voltmeter, we can now proceed in measuring current using ammeter. Here we have a 9 volts battery and a 1K ohm resistor. Using our ammeter, we will measure the current through the resistor. But before that, let's have a quick calculation using Ohm's law to compute the ideal current along the 1K resistor. Based on Ohm's law, current is equal to voltage divided by resistance. Now, current is equal to 9 volts divided by 1000 ohms. The answer is 0.009, or 9 milliampere. Let us set the ammeter to 25 milli. Here, we will look at the meter range of 0 to 250, and use a multiplier of 0.1. The expected reading we should get must be around 90, since the product of 90 times 0.1 is 9, and since we are using 25 milli, we shall express it in milliampere. Then we get the value of current as 9 milliampere. We'll connect the black test probe to negative terminal of the battery, while the red test probe to the resistor terminal. As we can see, the pointer deflects on 90. Therefore, we have a reading of 9 milliampere. And that ends our analog multi-tester tutorial. For any questions, comment it down below. Thanks for watching.